again. So I'm going to start by welcoming you all. Good morning, good afternoon, good evening. Probably you are surprised that we are having such welcoming, and why I'm saying good morning, it's because, well, at my place it's just perfectly noon, but probably we are having people with different, we have participants from Australia, Middle East, Mexico, Brazil, Lativa, so we try to be as inclusive as possible. So on behalf of CPEX Global, I'm Anastasia, and I would like to welcome you all to ISO 12647, heading for printing process, conformance, and standardization. You might all know that in Germany, there are 250 printers that are ISO certified. So this is important to be ISO 12647 if you are associated with the printing business, either flexographic, offset, or rotogravure. So in this session, we have an amazing trainer, Dr. Abhay Sharma. Hello, welcome.
Good morning.
Who has an amazing professional experience in color management and that particular ISO implementation. In this session, he will provide you insightful learning for various parts of that, requirements, implementation criteria, etc. Give back voice to Dr. Abhay Sharma, that is going to do the great presentation for us today. I will remind you about the break in 1 hour or so, so everyone can feel comfortable and have their needs met. Thank you very much. The mic is yours, Doctor.
Thank you. Thank you. Good morning, good afternoon, good evening. Thank you, Anastasia. Great introduction. So welcome. We have, this is our title for today is graphic technology, and we're heading for process conformance and standardization. We're going to be talking about color, about numbers, measuring. And here you see a number, ISO 12647 is one of the main standards that we'll be talking about. One more parameter that does affect all of our printing is the total TAC, total area coverage. And when you add up CMYK, we can actually get 400%. So if you add up 100 of C, 100 of M, Y, and K, you can get up 400%. But what we talk about when printing halftone images is a maximum of 320 on a good substrate and really a lot less than that on others. And so each of the printing processes and papers would specify the total amount. And you don't need to worry about this. This is really usually taken care of in choosing an appropriate profile, but it is a parameter that we see in 12647-6. So all I'm talking about here is based on 12647-6, and these are the different things that together will form the certification for this category of printing. But this 320 is really a higher level, and that's when we add up the ink percent in any part of the image or graphic should not be more than 320. And many of the programs will do a stain to show you this. If the pre-press department has done their job and applied the correct ICC profile, when it comes to us, it won't be like this, and it won't be greater, and we won't have ink and ink pooling and problems with smudging and smearing and drying on our print process. Good. So here we have the substrate color, and you can't really deviate from this. As the customer asks for something, then you have to do the substrate they want. But in general, if we're printing to the standard, then we have a range within which we have allowable color of the substrate. And so newsprint, of course, is very is not very white. Packages film may have a very different white of the substrate. And then, of course, offset may. And we're going to talk a bit about optical brighteners in a moment. But basically, if we want to print to the standard, we have a range of media colors that we would like to deal with. And the reason is that the ink falls on top and interacts with the media. And so we can't obviously get any brighter than the brightest media. And so that's a limitation on the white point or the highlights. But really at the lower dots, and with the microscope, we saw when there's less ink, we're seeing more of the substrate. So when there's less ink at the highlights, there's more of the substrate, and therefore the color of the substrate is really relevant for the highlight areas. When there's more and more ink, as we saw under the microscope, you're not seeing much of the substrate. So it really does affect some colors more than others, but we need to consider it. And then we're talking about, the LAB system again here, and we'll do the LAB system tomorrow. But here you see the L star is the lightness, A and B are the color, and this is the amount of tolerance that we can have. And this is all measured in the right way up, in a instrument. And the white point is automatically picked up in any of the software that you're using, because in all of the targets, all of the charts, there is a white. And so the software that measures this will always pull out the white point and report that. And that's what it's here. So in summary, the media is very important, especially for the highlights, because there's not much ink there, and we're really seeing a lot of the light come up from the media. It's also a limit that as you put ink, it gets darker and darker. And so you can't get any lighter than the media. And the media here should be greater than 85 in the top of this slide. But as you put ink down, the lightness drops. So you can't get any lighter than the media color itself. And that's why it's specified here. There are two levels here for wood-free coated and uncoated, and for gravure, we'll see tomorrow, super calendared paper, SC, and LW, lightweight. Any questions on the media? It is a big issue for all types of printing. Something else that is specified for flexo inks is the color in terms of the hue angle. So, so important point here to make, folks. For most printing, we talk about the solid ink density, but for flexo inks, we talk about the hue angle. Okay, so the color that it can be. And you know what? I wonder. Here is a Munsell color tree. So I'd like to just show you that and get my camera up here. Here are hue angles. Okay, so we go around the whole color sphere with hue angles. And so the ISO specification -6 only talks about what angle the C, M, Y, and K should be on. So here's the yellow, and we talk about the yellow at 93. So it has to be at 93 degrees, but it doesn't talk about how dense the ink should be. And so we need to consider how it gets from there to the final edge, but all we talk about in the standard is the angle or the color of the ink. And you have that conversation with your ink provider. And so if they're providing you inks that are to the standard, they have to measure at this angle, but how dense you make them, how far they go out is based on the viscosity of the ink. Right, so the so the final density is metered, and that is via the density and the viscosity. So so here are some of the parameters that are used here. And this is, again, in terms of the delta EAB. So it all comes back to delta E. And I'd like to do this. I'd like to do a delta E problem so we can actually see that. Gloss, and I hope we have a gloss meter, certainly on some of the shinier substrates. Of course, that is specified. Here's a gloss meter. It's different to a spectrophotometer. It's very simple, easy to use. I've actually seen chocolate being measured because the gloss of chocolate is often measured. But okay, so here's the a gloss meter. It's a very relevant parameter for the shininess of many packages, and that has a value within which how it should be measured and what the values are when it is measured as part of 12647-6. Here's the shiny material that you may see. And while light and color is 0.45, gloss is other angles. So remember I said color is 0.45, but gloss is measured at different angles because we know that as we look at a material, it has a different reflective properties. Here's the here's my camera. Anastasia, I don't know if I can't see my camera again, but can we see this? Oh,
your camera is working. Is everything fine?
Yes. Okay, thanks. So it is possible to get one of these. You get them and then you put them on top of a uniform tint, and then that will this pattern that you see here will occur at the dominant halftone screen ruling. So usually we set this in CTP. But if you want to check on the printed sample, you can get one of these cards, and then on a uniform tint area, it will create this pattern that you see here to confirm what was used. And there's the screen ruling as you image. It used to be on plate, on film, and then on plate, but now it's very nice that it's set as that. And so we have that, and we need to consider the resolution from the original image through to these other forms. Is there TVI? I want to talk about tone value increase. I want to talk about dot gain here. I think I have it in the next slide. Okay, dot gain and TVI. And so the dot in all types of printing, but in Flexo in particular, we need to think about the dot percent. And the dot, as it gets smushed, grows physically and optically as the light bounces up amongst these dots. And so these dots grow. So in pre-press, in the InDesign, Illustrator, Photoshop PDF file, we may say 50%, and it looks like this on our screen. But the final printed product, due to this growth, both physically with the different smudging and pressing and hitting the media, as well as optically as light bounces about, the 50% grows. And this is called TVI, tone value increase. The older name was dot gain. And the 50%, if you measure it now on the final printed product, is often more, up to about 20% more. The growth in the midtone of 50% is nearly 20. However, it drops off at the top and the bottom of this scale. So the dot gain is measured and it grows from the digital file of 50 to about 70. On the 20, it may go from 20 to 28. On the 70, it may go from 70 to 78. What we would like is to know this dot gain and if necessary, reduce the values before they go. You can't get away from it. There's no, I send 50 in the digital file and I get out 50. It will always grow due to the printing process. We need to know what it is. We know that it is maximum in the middle and smaller at the both ends of the scale, maximum at the 50, smaller at the ends, and it may be different for the CMYK. We don't want it to be different because we want a gray balance, but it may be different for the different inks and the different printing units that we have. So we have CMY, they're different printing units. Sometimes they're an older one, a newer one, maybe a different analogs on one of them. But the overall dot gain, we would like to be the same for the three CMY and K, but they can be slightly different. And the final bit is to talk about the communication. And I would like to talk about the CXF for a minute. And so basically all of these topics that we've talked about, you have to consider and measure each of these topics. And so that's what we're doing here. So everything from dot gain to the gloss, to the LPI, to the dots, all of these things we need to know and consider, because the overall certification results in is an accumulation of all of these. So it's a bit like a car. It has to do the miles per gallon. It has to achieve a particular speed and acceleration. It has to have a towing power, a capacity, the engine size, etc. So it's many of these topics that need to be done together. Are we familiar with PDF X4 and the CXF? So number one, the PDF file that we would like to share and receive and print needs to consider the ICC profile and the color spaces. And so luckily we have PDF. It was originally an Adobe spec, but it's now an ISO standard. And it provides us the information that we need. Let me just get rid of some of these. So we need the PDF file. This is part of the spec because for packaging, it has been so complicated and people using different software systems. For the -6 spec for flexography, it has actually been specifically spelt out. And in particular, PDF X4, that actually for all of them, but the CXF for spot color specification is primarily promoted here in -6. And what we, so the spot colors are specified, the 100% is specified as a Pantone color perhaps, and it's got a LAB value. But what we don't have is how it goes from the 100% to the tint values. And so we have a CXF file format, which is just XML, and it's like a text file. And that provides us spectral data measured over black and measured over white for the spot color. And from that, we can predict how that breakdown of a tone value would work for spectral data. Is anybody using CXF data? You don't explicitly need to know this, but it's part of a part of this standard is CXF spectral data. So can I see a show of hands? How many people have spot colors in their in their jobs? If you're doing Flexo, you are going to be doing spot colors. Any thumbs up for spot color printing? Can we do reactions? David, good. Golf cartons, are you doing spot colors? Louis Len? Sandis, we do a lot of printing with spot colors in offset printing. Sure, sure. Gulf carton, 2 special colors only. Okay. So you have a 6-color press? Heidelberg XL press, sure. So for offset, was that 105 or 107? 8-color, 10-color as well. Yeah, good. Anastasia, I make a suggestion for CPEX that we do expanded gamut. All of our clients here, we really need to do expanded gamut.
Yeah, sure.
Okay, so sorry to distract. Anybody heard of expanded gamut, CMYK OGP for offset flexo, even digital printing? Okay, good. Yeah, so people have, so obviously it's spot colors. Okay, so for spot colors is this CXF, which is part of the standard and involves communication of spectral data. So I don't know if I have it thing here. So LAB is just 3 numbers, but spectral data is every 10 nanometers. So it's the spectrum measured. From this spectrum, we do compute LAB. And so a lot of the standard has LAB values, but then for spectral data, for spot colors, we have spectral data. So maybe I'll just do that as a quick text here. Or, in fact, why don't I do this? So I just want to, oops. Is this a good text color?
Yes, everything is visible and readable.
Yeah. So LAB is fine, and that is used throughout the standards, but it's just a summary of the spectral data into 3 numbers that are measured with an instrument. And so you'll see here, in fact, there are 3 colors, 3 numbers, but we can also, I don't know if I'm quickly going to be able to go to the spectral data. So that color also has a full spectrum. And for spot colors, data is specified in the standard to be via the spectral data. Let's see if I can quickly. Okay, what I had measured has that LAB or this spectrum. In fact, it was just measuring the air because I just pressed it without putting it on a substrate. So here's the spectrum, and it is every 10 nanometers. So it's a continuous, not continuous, but more than 1 point. So either the 3 LABs, and I can go back here to the LAB values. If I go back, I can go back to the LAB. So it's the same information is shown as 3 LAB values or or a graph. So this is pretty important. So either it's 3 LAB values or the whole graph. And for spectral data, for spot colors that have these tone values, we would like to use the whole spectral graph. So spot colors are complicated, especially for tints. So the standard specifies spot colors must be in spectral data and encoded in XML, which is just a text file, a CSV text file, and the structure of that is called CXF. So it gets slightly more complicated for spot colors, but that's unique to Flexo. And I'd like to hear, has anybody had challenges with this? This is kind of a newish area that is supposed to help spot color reproduction. I've lost the chat.
Please,
Okay.
because the recording stopped. Okay, now please repeat the last sentence.
Yeah, okay. And so here are the requirements that we need to be able join in and not join in.
Exactly.
Maybe it's, you know, how long has it been? So we didn't stop it at the break time. So tomorrow we stop it at break and then start again.
Yeah, probably that's the best. Yeah.
It's gone. Yeah, it's got to the limit perhaps of what it is. I don't know.
We'll see. We'll see. It should be good now.
Yeah. Okay. You'll have to add them all together. Okay. So folks, this is the summary, and this is the practical application is for you have to have all of these parameters and know what they are, have instruments to measure them. So there is some cost there. All of the software is already set up to know these. And so you just, from a drop-down menu, choose 126.126.47. Minimum printable dot we talked about for Flexo because it's got the highlight dots that get knocked off. Screening parameters, tone value sum, the TAC, 320 is really the absolute maximum. Surface finishing requirements, inkset gloss, and reporting requirements. And then this CXF as spectral data. And so the instrument, the minimum instrument is a spectral data, a spectral instrument that we may need to measure. So really what you're interested in is practical implementation of the standard. So you want to be able to meet the standard and print to the standard. So CDI, GMG, ESCO, any workflow or process system you have will have this reporting, and there'll be a very nice screen that you can use. Often measurements will directly go into this report. It has the default 12647 standard fields here, but if your customer has something they want to add, you can add maybe the specific things. But basically 12647 has the reporting requirement, and all the software that I know already has this. And so you just need to be able to measure it. And then most software will give you a pass fail. So on the screen here, this software that we're showing has, you can see, if you look closely, green and red numbers. And then overall, there would be a yes or no. So there are many systems that are part of the ESCO, Heidelberg, Fujifilm, or there's separate standalone monitoring systems from X-Rite, etc. But they'll all have this predetermined 12647 reporting template, which will automatically have these boxes and will automatically have these tolerances. And you can deviate from these tolerances manually if you want to show something to pass. So if you have these fail, you can make them pass by changing the software, but then you're not printing according to the standard. So that's how it works in practice. But you have to have the instruments, and then you have to have some software that does it. But it's already there, folks. This is you don't have to invent this. Some people do. They will get a consultant to come and help them, and they'll set up an Excel spreadsheet. But in the main, this is all there. It's cloud-based in all of the systems. It can continue to track and continue to monitor and continue to have this. And so when the customer comes and has this shipment and they say, this isn't right, you then go to that. It was printed 2-3 weeks ago. You go to this file and you open it up and you see whether it had all of these tick marks. And this should be automated, not relying on somebody at press site to take these measurements. The software should force it, otherwise operators are not going to input this data and report it. So as much as possible, it should be in sheet measurements, or somebody shouldn't allow this to be signed off until these measurements have been inputted and we know what they were. And of course, unless you put a control bar in your job, you're not going to be able to get any of this data. But this is all there. We just need to use it and then have this printout, and you can print this report as a PDF and you can attach it with the job, with the shipment to the customer, so they can see what was measured and what was pass or what was fail. Usually everything should be a pass or within the tolerance. Some of the tolerances are, don't really matter. There's something, for example, for the yellow, we can have a bigger allowance. We don't see much yellow, so the yellow can have a bigger tolerance. Or you can see for the cost of reprinting, you can have some wiggle room. But in general, all of these should be green. They're achievable because this is a printing process that these standards have been written in respect to the printing process. It could vary across the world, from Europe to the US to the Middle East and Far East, but in general, that's how it works. And it's amazing. It's lovely for everybody to see a green tick mark here. Everybody feels happy. You don't really need to know. Most of our customers and print buyers are not going to know what all this delta E is and LAB is, but they will get this report that just says pass, and so they say that's good. So that's how we would like to go forward.